Today we're going to be looking about waves. Waves transfer energy and information, but they do not transfer matter. So they don't transfer like real stuff, but they transfer energy. So you really need to remember energy and information. There's two types of wave, longitudinal and transverse, which we are going to be looking at now. Longitudinal waves. The vibrations occur parallel to the direction of travel. So if the wave is going this way, the vibrations are also going this way. So parallel to the direction of travel. Transverse waves, the vibrations occur perpendicular to the direction of travel. Perpendicular just means at right angles to. So if the wave is going this way, the vibrations are going up and down. We're going to be looking at a diagram soon. So a longitudinal wave, we'll look at some examples. So there aren't that many for longitudinal, but sound is a big one. And also for seismic waves, P waves are also longitudinal. So we need to remember sound. Transverse wave examples, there's quite a lot. So all the members of the electromagnetic spectrum, we're going to be looking at that in a different video, but some of them are radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Now we're going to be looking at the wave equation. So that is wave speed is equal to frequency times wavelength. Now the units are... Okay, so that's how we calculate velocity, or that is the wave speed. So this velocity we're talking is really the wave speed. Okay, so now we're going to look at labelling a wave. So got some letters. So A, as you can see over here, this is the top point of the wave and it is called the peak. Now B, over here, this is the bottom point of the wave and it is called the trough. C, over here, is just, what we're asking here is the distance from here to here, and this is called the wavelength. Now the wavelength is from one point on the wave to the same point on the adjacent wave. And this D over here, from here to here, is also a wavelength. So you don't need to worry about writing that down again. And what this diagram is actually trying to show us is the wavelengths. So wavelength can be from any point on one wave as long as you draw it to the next line on the next page. So from here to here is one, from here to here is one, from here to here is one, and from here to here is one. All wavelengths. Now this dotted line over here, shall we call that E? This is called the equilibrium position, or the undisturbed position, or the baseline. So this is the transverse wave, the one that we were looking at. Now, a longitudinal wave looks like this. So, on a longitudinal wave, there are areas of compression and areas of rarefaction. And if we want to see wavelength, then that is just from one area in the compression to the next compression same point. That, for example, would be etc. So now we're going to have a go at labelling a wave. So can you pause the video and label points? Yeah, so just label the points and we'll talk about them after. And I remembered that I forgot to talk about part E, so we'll talk about that now. A is the peak, B is the trough, C is the equilibrium position, D is the wavelength, and E is called the amplitude. So the amplitude is from the peak to the equilibrium position, or from the trough to the equilibrium position. The higher the amplitude, the louder the sound. The smaller the amplitude, the lower the sound. So example for this would be a whisper because it has a very small amplitude, as opposed to this, which would be like a shout because it has a high amplitude, so therefore a louder sound. Hope this